For this question, evaluate the following if the limit exists. First of all, we can see limit approaches x to 2. For this function have modulus. So for modulus, we need to express it in piecewise. So the piecewise will be positive for this x minus 2 more than equal 0. And negative for it to be less than 0. So we simplify the domain where x is more than equal to. This one is for x less than 2. So we can see we have changing of function at the x equals to 2. When more than 2, our modulus is using the positive x minus 2. So means that at this side, the function will be x minus 2 to represent the modulus. So for x less than 2, the function will be negative function of the modulus. So back to the question, it asks us to find the limit of this function when it approaches 2. So when it approaches 2, we can notice here, left-hand side function and right-hand side function, it is different. Therefore, to find this limit for this function, we need to find it from left-hand side and right-hand side. So first of all, we find it from left-hand side. So when we find it, x approaches 2 from left-hand side, the function involved here will be x squared plus 4x minus 12. With the modulus x minus 2, we select it is the negative function. And then we try to evaluate this limit, substitute 2 into the function, we get IDF. So for IDF 0 over 0, we need to simplify this function by factorize. And we can notice that the factor of x minus 2 can be simplified. Now we evaluate our limit again. When x approaches 2 from the left hand side, we substitute inside, we get 8 over negative 1, which is negative 8. So after we doing the left hand side, now we proceed to the right hand side. So limit approaches 2 from the right hand side, the function involved here will be x squared plus 4x minus 12. And for the modulus part, when it's more than 2, we are taking the positive function. So we try evaluate this limit, substitute the x equals to 2. We can notice we get IDF, so we need to simplify this by factorization. And the factor of x minus 2 can be simplified. Then we substitute our limit x equals to 2 into the function. So it is equals to 8. We can notice that our limit approaches 2 from the left hand side and limit approaches 2 from the right hand side, it gives us different answer. So when we want to evaluate this limit around the value of 2 here, it will be does not exist because the limit left hand side doesn't same with the limit right hand side. So we give out our reason saying limit approaches 2 from the left hand side of the function not equals to the limit approaches 2 from the right hand side of the function. Therefore, to evaluate this limit approaches 2 for the overall function, it will be does not exist. So now we look at our important marks here. First of all, when we meet the IDF in terms of 0 over 0, we do factorization to simplify the factor x minus 2. Then we get the answer for this limit. So same happen to the right hand side. And we must select the correct function according to its domain. So for the left hand side, we need to select the function of the modulus with negative. For the right hand side, we need to select the function of modulus in piecewise form with positive function. Then with the reason saying left hand side limit is not same with right hand side, we find out this limit does not exist. Then we continue for part B. Limit for this function as x approaches to 1. So we look at our function here. It is a one-piece function. It is not piecewise function, so we can evaluate this function directly. When we substitute 1 into the function, we can notice that it is also 0 over 0 IDF. To simplify 0 over 0 IDF with the function involving cert, we were going to multiply with its conjugate, where the conjugate of 1 minus cert x will be equal to 1 plus cert x. So for this function, we don't need to do left hand side, right hand side, because this function is not piecewise function around the value of 1. So if you compare just now, the function around x approaches to here, it have two different functions. Here is a piecewise function, so you need to do this limit at left hand side and right hand side to get the answer. So come back here, multiply with its conjugate, it will give you a squared, which is 1, minus b squared, which is x. And denominator, we will rewrite it in the term of multiply here. Then we can see the factor of the conjugate here. The factor of IDF here, 1 minus x, can be simplified. Then we evaluate our value again. Substitute 1 inside, it will give 1. And then from denominator part, it will be 1 plus 1. So finally here is 1 over 2. So what is important here is the first one is multiply with its conjugate when we have 0 over 0 IDF. And then simplify and evaluate our value inside to get this answer. So that's all for this.